Okay, we've got a formula connecting speed, distance and time. So speed is equal to distance divided by time. It's kind of them to give us that. And we're told that D is 160 to two significant figures. And T is 7.2, in case you can't see that on cam, 7.2 to two significant figures as well. So they're both to two significant figures. And we're asked to work out the upper and lower bounds for S. And we're asked to give our answers to three significant figures. So watch that one because it changed it to our answer is three significant figures. So don't lose an easy mark on that. So we're looking for S. So to do our lower and upper bounds for S, we need to do our distance divided by our time. And our distance divided by our time are where we've got our rounding errors as such. So before we can do the speed, we need to think about what are the upper and lower bounds for our D and our T. So if D is 160, I need to have a quick look at what are the upper and lower bounds for that one before I can do my calculations to get S. Then I'll do the same for T, which is 7.2, and I'll look at my upper and my lower bounds for that. So you can obviously just write UB, upper bound, lower bound, whatever you want to do, or to be fair, if the examiners see the numbers, they know that you must be doing those calculations. So if it's 160 to two significant figures, what that means is there's your first two significant figures you've rounded based on that one there. So they could have said two significant figures, or they could have said about the place value location, so it's rounding on this one. So these are our units, tens, hundreds, so it's rounding to the nearest 10. So if this has been rounded to the nearest 10, we need to think about what is the upper bound and lower bound for 160. So we want to think if the next 10 after it's 170 and the 10 before it is 150, what are the upper and lower bounds for that number to keep it at 160? So we know that the highest it can go is 165. Now when we use this, I know people prefer 164.9999999, but in terms of calculations we can use the extreme upper bound, so 165. And then the lowest it could possibly be to keep it at 160 is between the 150 and the 160, so 155. If you can just do these without any work, fabulous. And then the second one is also to two significant figures, but because that's 7.2, let me just write it there, and it's been rounded to two significant figures, so there's your 2, and its cut-off point is there. This location is in the tenths column, so it's been rounded to the nearest tenth, or we could also say like to one decimal place. And we just need to again consider the one before it, so the tenth before it is 7.1, the tenth after it is 7.3, and again we just need to think about the bounds for that one. So between 7.1 and 7.2 is 7.15, and between 7.2 and 7.3 is 7.25. So there is our upper bound at 7.25 and our lower bound at 7.15. Okay, so the final thing to now do is work out your upper bound and your lower bound. Now there is a way that you can do this where you just literally try all the options and then pick the right answer from it. So because all we're doing is doing our distance divided by our time, if in doubt, that's what you could do. So take one of the D's and divide by the T. So we'll focus on the 165 to start with. I could do 165 divided by 7.25, and I can do 165 divided by 7.15. It's just to be sure and be patient that I'm not going to make any mistakes, and I'll just see what my answers are in a minute. And then likewise I could have picked the 155 instead, so use the lower bound. I could divide it by the upper bound, or I could have divided it by the lower bound. Now if you do all four calculations, it just means you're not going to make a mistake. So let's just quickly do those in the calculator. 165 divided by 7.25 is 22. Oh, and the question said three significant figures, so as I take them off the calculator, I will do them to three significant figures. So I'm thinking in advance. So three significant figures is 1, 2, 3. That's my cut-off point there, but I just need to check does it round. So that's 7. If I look next to it, it's a 5, so it's going to round it up, so it's 22.8. So that just saves me some work later. So that's that one. And then this one, 165 divided by 7.15. And if I do that on the calculator, that would be 23.0. That's my cut-off point for 3 significant figures, but I peek to the next one, and the 7 is going to increase that 0 to a 1, so 23.1. Next one, 155 divided by 7.25. That gives me 21.4. Obviously, again, all I'm doing is just the rounding on these, so you can do those as well. And then the last one, 155 divided by 7.15 to get 21.7. So I've got all my 4 answers here. So remember these, this is always important to think about the context of the question. So these are speed. So if D is, we don't get the context of it, but say a speed is so many miles per hour, then our upper bound is obviously going to be our biggest one. So 22, 23, 21, 21. So this is going to be our upper bound. 23.1 is our fastest. And our lowest speed is 22, 21, 21. These are both 21. So 21.4 is smaller than 21.7. Think about £21.40, £21.70. So our lowest is 21.4. Now, obviously, if you want to speed that up, and you can logically think about it, to get your largest answer, which is this on here, it does make sense to use your upper bound divided by your lower bound. That is logical, so you can do it through logic alone to save yourself some time if you're happy with that. And to get your lowest, so our 21.4, we took our lowest bound and we divided it by our upper bound. So if you take a small number and divide by a bigger one, it's going to give you a smaller answer. Likewise, if you take your largest number and divide by your smallest, it will give you your largest possible answer.